And we are going to maximize the volume. So let's write down an equation for volume of a box. In general, how do we write the volume, or how do we find the volume of a box? So once we substitute in something with x and for length, width, and height, that is going to be the thing that we're going to maximize. All right, so basically what we have going on here is we cut these values of x out from each of the corners. And if I folded like where these dashed lines are and folded these sides up, so now where I'm highlighting, that would be like the base of my box, and the non-highlighted part, that's the sides that are getting folded up. Okay, so remember this whole piece was 25, the whole thing was. But now when we fold up the corners, this length of the box will only be from here to here. So what would be an expression of the length of the box? Look at you guys. Okay, so we have 25 minus 2x. And our expression for the width, if this was 20 and we took off now x on each side, would be 20 minus 2x, right? And the x would become my height. Okay, so that is my equation that I am now going to maximize. So here's what we're going to do. We are going to multiply this out by hand. We are going to take the derivative. It is not a factorable one though, so we are going to have to use quadratic formula in our calculator. Yes?
So is it supposed to be 20 or 20?
20 minus 2x. Oh, Jolly Rancher. Thank you. 20 minus 2x. All right. Now, I am going to multiply the first two together. Then I'm going to distribute the x throughout. What's 25 times 20? Oh, no, yes, Nathaniel, good. 2 times 25 and then add a 0, right? 50. Okay, all right. Now this is minus 50x minus 40x. Ooh. Isn't that minus 90x when you put that all together? Right? Because minus 50 minus 40. Okay, and then negative 2x times negative 2x is plus 4x squared. And now we distribute the x to everything. So our volume equation, and I'm going to write it in standard form. So I'm going to put the 4x to the third first, minus 90x squared plus 500x. Are you with me so far? All right. When I'm maximizing, what am I going to do? We're going to take the derivative and we're going to set it equal to 0. Or undefined, but because this is a polynomial, it's not undefined anywhere. All right, what do we get? 12x squared minus 180x plus 500. Here, this is not, we cannot plug this in quadratic formula. Here's what I will tell you. If you want some smaller numbers, you could divide off they're all even, right? I don't think 6 goes, well, no, it doesn't go into 500. All right. So if you wanted to, we could do this and just at least have some smaller numbers to deal with. But we are going to have to find the 0 of this by using quad formula. All right, so x equals what? Negative b plus or minus. What comes next? Square root p squared minus 4. In a second, we're gonna get the same answers as if you didn't notice to pull the 2 out. It's just that they're a lot smaller numbers to deal with. All right, I need somebody to evaluate underneath the square root for me, please. Did you get 2100? Let's go ahead and round that to 3 decimal places. 45.825 if you truncate, 826 if you round. Okay, so are you getting what I'm doing right now? So we're going to do 90 plus 45.826. Our answer divided by 2 is 67. It's about, well, crapola. 135.826 divided by 12 is 11.319. Then let's do the minus. Did you notice the new air freshener in here? No, really. It's laundry day or something. No, linen and lavender maybe. It's really nice. I like it. Okay. Now we should check and see, how do we know if it's a max or a min? Which I guess there's a couple different ones that I would check. I guess I need to check both of them. I think that since we're on this track and we don't have a nice number, we didn't have nice numbers to do a sign chart for, let's just do the second derivative test since we need to review that anyways, okay? So what would the second derivative be? 24x, if I went up to here, 24x minus 180. So what we're going to do is we're going to plug these in here and we're going to check out what kind of interval it is on. I'm going to just plug 11.319 in, okay? Okay. 91.656. You guys got to confirm this because you know I've been making a lot of mistakes today. Right? Okay, if this is positive, this is on a concave up interval. What kind of extrema is this? Look at the picture. Do we want a minimum? No. Okay, let's check the next one. Negative 91.656. That means this is concave down. This would be a, so this is a max. All right, let's go back and then finish the problem. Remember we wanted to find the dimensions of the box, right? And this is, the 3.681 would be x. So that gives me the height of the box, right? 3.681. What were the units? This is inches. How would you find the length of the box? Can't you just plug it in here? Would you do that for me a second? Did you get 17.638? And then finally, we're going to plug it in for the width. So 20 minus 2. Okay. Let's take a look at example 4. I think we did one like this before, but I think it's worth doing another example together. So, often on an AP exam, you're going to be asked either like minimize distance, like where you have to use the distance formula, or sometimes you're given like some kind of a shape, like a rectangle. I'll give you one to practice. And your rectangle is like defined somehow by some kind of curve, okay? And this one, it says its base is on the x-axis, so its base is going to be down here. And its upper two vertices on the parabola y equals 10 minus x squared. And so if we graphed 10 minus x squared, I don't know why. Okay. Delete. 2. Okay. It's a parabola opening down. Where does it touch the y-axis? 10. And it would touch the x-axis at plus whatever plus or minus the square root of 10 is, but we don't know exactly. So what we want is some kind of rectangle. I'll draw one of the rectangles. There's a lot of different rectangles that could be formed depending on how high you made it up the parabola. So if you go further up the parabola, it's longer, but it also becomes skinnier. Okay? So I want to try to find the largest rectangle at what point. And so we have this point here, x comma 10 minus x squared. So we're trying to maximize the area, and how do you find the area of a rectangle? Length times width. All right, so as long as we can write here what we're doing, that is the formula we're going to use eventually to maximize. Now, we have to write this in terms of x. Any ideas for the length of my rectangle? If this is an ordered pair, that means that's x. 2x. What would be this distance? Okay, would you guys expand that for me, please? Now what? Derivative. And? Set equal to 0. Okay. You try it. I'm going to freeze this. When you're done finding x, then just pause a minute and I'll show my answer and we'll see how we did. that what you got? What if you did 20 over 6 square root? Is that wrong? No. They wouldn't even mark you wrong on a free response. They wouldn't mark you wrong for not simplified. They wouldn't. Did you guys all get that? Now what do we want, a max or a min? Because which one is? We want a max, and now we should confirm that it's a max. And here's the deal, guys. This is a rectangle. Are you going to have a negative length of a rectangle? No. But if I ask you to confirm, you should use the second derivative test to do that. And it's pretty easy. What's the double derivative? Negative 12x. So literally, guys, if you put a positive value into it, it would be negative or concave down, right? So all I need to do is this. We're going to just show whatever this is. We know that it's going to be greater than 0. I have to draw a picture because I can't do it. I really screw it up every time. I have to draw the concave up. Oh no. This is less than 0, isn't it? How come you guys just let me do that? When you do a negative times a positive, isn't it negative? Yes, that's less than 0. That's concave down. So a max. Okay, are we good with that? So, going back to the original, the length was 2x, so it would just be 2 times 10 over root 10 over 3, and the width is 10 minus that squared, so whatever 10 minus 10/3 is. Man,